this is a Simmona colony. So this is a cluster, another cluster fungus, but this is cluster Simmona, not Simmona. So this is, you can see, these are the micropores of the Simmona fungus. So this will be we'll be viewing in the under high power magnification. This is the Simmona colony. This is another Simmona colony, as you can see. So this is a little bit distorted, but it is the original growth. If we morcellate it properly, then we will see the proper growth. So later on we will be morcellating. This fungus has been operating in from pumpkin. So the microphone is focused and it is getting again focused. So you can see the image. So you can see another Simmona colony. There are lots of Simmona colonies. So micropores are there. Micropores are visible. This is another Simmona colony. And this is also visible. So this is a tattered Simmona colony. This is growth is very irregular due to the culture medium. So we will have to morcellate it and take a specific amount of the tissue, and we will have to put it in a second culture medium. So the growth will be uniform. We will be able to see it, visualize it properly. This will be done in the second session. This is a preliminary video we are watching. This is the preliminary microscopic observation of the Simmona colony. So this Simmona colony we will see. Another Simmona colony, another Simmona patch. Actually, this is not a colony, this is the Simmona patch. You can see this the phase contrast image. The outside periphery you can see very well. It's a very big Simmona patch. Another Simmona colony. This is also a big patch. This is a big patch colony. These funguses are mainly formed due to the vegetables are kept in cold storage for a long time, and they are said to us that they have been supplied fresh, but it is not fresh. The funguses are fresh, but these vegetables are not fresh. Anyway, you can see this Simmona colony. This is a medium colony. And the Simmona colony, this is a little bit focused, but we are going to focus the microscope, and you can see the Simmona formation, the clinging Simmona formation floating in the culture media. These are the small Simmona colonies as well. And many more colonies will be visible after it is kept in, if it is kept in more another say 5 days or 6 days session, it will be more colonies will be visible. But what will we do? We will actually change the culture media. We will just morcellate the tissue, and we will change the culture media, and then we will be able to put it in the next culture media, and we will see the more growth. We can see the more growth fashion, and that will be good to observe. because this is the rough growth. We need a uniform growth to see, so that we will be able to see the colony better. This is just a preliminary vision, as I am telling you. This is a very preliminary vision, but the fungus has been identified. It is Simmona colony. It is It is cluster Simmona, not Fumonera. It is cluster Simmona. This is a different kind of cluster fungus. This is as bad as Fumonorium, but maybe much worse. That will be finally defined when the mycotoxins are getting identified. Maybe this will have some similar mycotoxins like Simmona. Hello friends, we are now back again with this same fungus. Now you can see it has been morcellated, and it has also been separated by the centrifuge. Now we are going to remove this fungus from its previous culture medium, that is the LST broth. So we are going to remove it, and you can see the fungus layer. It's a brilliant yellow color, as you can see in the front. This is the fungus layer. So we will keep that fungus layer, and we will separate out the culture media broth behind, and we will be putting it into the brilliant green bile broth. This is the second edition of this fungus broth, and we will look over any more bad thing is there or not, and we will also culture the growth of the Simmona fungus, as we have said, in a scientific, in a more regular fashion. So let us first remove this culture broth by the pipette help of this pipette. We will just discard this fungus broth, but just not disturbing the fungus layer as it has got separated. So we just separate this out, and as you can see, it has been separated. Now we shall put this brilliant green broth inside this fungus, just simply discarding the pipette tip, and we just put some brilliant green, this brilliant green broth. As you can see, this is the brilliant green broth. You can put this near to the camera, and you can see this is the brilliant green broth. So this is the broth. So this we will put by the help of this pipette, and just around 6 ml or to 10 ml we have to put. Okay. Okay, now this is around 5 ml. So the broth is there, and another 5 ml. So the broth is already there. So we will just shake the pipette, shake the tube, shake the culture tube, and just do this, and just shaking the tube. And to mix it, already the gas discharge has started. We just shake the tube to uniform mix the culture media with the tissue, the fungus. With the fungus, it's almost mixed up. Something is there in the bottom, and it has mixed up. So already the gas has started coming out. So just pour this thing into the culture flask, and that is it. So this tube needs to be discarded. So it is done. Now we will just swirl the flask and cork it. After a few minutes, after keeping this flask for a few minutes in just standalone position, we will check the concentration of the this Simmona fungus. Just simple corking as I have done. Now that is done, and just keep it like this for a few moments to settle this fungus in the culture media, new culture media, so that we can look for it. For just about 15 minutes we will be settling it, and we will just look for it. So friends, we are back after 15 minutes, and we can just see the fungus. It is there for sitting for 15 minutes, and now we will be examining the fungus, just the simple morphology, to get the starting morphology, because after changing the culture media, what has happened to the fungus, that we will be examining. Because during morcellation, sometimes the fungus gets very much lacerated or very much teared up. So that makes a very bad, the system anatomy of the fungus gets damaged. So whether it has gone damaged or not, or what has happened, let us see. Or rather, we will see if the growth has started or not. Growth has already started or not. What is its beginning? So let us, that we do examining. This is just a preliminary morphology. We will be just examining with the help of this fungus, with this from this culture media, from this new media. Just as simple as that. We will take just around 3.5 ml of the fungus, and it looks good, but let us see what microscope shows us, so that we will see. So let us see. So what the fungus is kept for us. You can see it is as good as present. The Simmona structure is as good. So it is heavily assimilated. This production is very heavy. This secretion is very heavy. Culture is complete. So more growth we will see after 5 days. Just we have to keep it in its brilliant green bile agar, bile broth rather. So after that we will see. This is a very big cluster. This is a Simmona cluster, as you can see. This is the clusters are there. This is the periphery you were examining, and it is fine. So it is getting focused, and it is fine. So it is good as it is. So it is there. The Simmonas are there. Simmona colony is there. Fine. You can see Simmona colonies. Lots of Simmona colonies are there. So it is there. As you can see, this the cluster Simmona, as the mycotoxin is visible. Now this is supposed to be patulin. The patulin rings are visible. You can see the coils in the video, and that is those the patulin rings. Supposed to be patulin rings, and more coloniforms are present. More mycotoxins are possibly present. Not only patulin. This coloniform, this formation of this mesh seems to be making more mycotoxins. So that we have to find out. Mainly the patulin is present, as you can see from the rings, but maybe more coils are present. This is the dark field view. It is getting illuminated, but this is some microsomes, micropores are there. These are flagellums. These are these are the clausters actually. These are the Simmona clausters, the patches, the Simmona patches. This is a very big cluster. This is a very big patch. The mycotoxins are yellow in color. It is getting illuminated. It is glaring actually. You have to put down the light. Now the UV light. It is a glaring patch. So many mycotoxins are there. That we will be getting from the UV spectrum very soon. So you will be getting that in the later part. It is almost looking like a skeleton eye, but these are actually the Simmona patches. It is not a skeleton eye. It is looking scary. So again you can see the Simmona coil, the patulin coils, these green color patulin coils. You can get the focused, and you can see the green color patulin coils. These are the marvelous patulin coils. So these are the patulin crescent, half crescents are there. The patulin half crescents are there. The broken sides of the coils. So as you can see, the mycotoxins has been revealed. The UV spectrum has come, and you can see this fungus is having 19 mycotoxins. So this is a very dangerous fungus as predicted. So it is having 19 mycotoxins. The peaks are there, the UV peaks are there, UV spectrum peaks are there. So it is having 19 mycotoxins from all types of sorts of things. The usiloxin is present, the tremogens are present, the moliniform is present, the patulin is present. Patulin is definitely present, moliniforms is present, and aflatem is present, the cysteine is present, zearalenone is present, ochratoxin is present. All sorts of mycotoxins are present. Most of the mycotoxins are present in this fungus. It's a very peculiar fungus. It is having lots of mycotoxins, 19 in all. So this is a very dangerous mycotoxin. This is a very dangerous fungus. As you can see, it is a very complex molecular structure, which will be revealed, which I will demonstrate to you in this later part of this video. In this presentation, later part of this presentation, I will be demonstrating that chemical structure. I will show you the chemical structure of the Simmona fungus. the mycotoxin of the Simmona fungus. So this is very bad, very dangerous fungus. As I am feeling, this is within 19 mycotoxins. So this is it. This is the UV spectrum of this Simmona fungus, as you can see. So this is the molecular structure of the Clauster Simmonna, the mycotoxin of the Clauster Simmonna. This is the complex molecular structure, as you can see. This is the full 19 mycotoxins is consisting of full 19 mycotoxins conjugated with the hydrogen bond, and this is a 3D model of this mycotoxin structure, the complex mycotoxin 19 mycotoxin structure. It is consisting of haploatoms. You can see the sulfur bonding is there, and that sulfur bond is SS bond is, that is the gliotoxin actually. So these are the mycotoxins, the mycotoxin, whole mycotoxin structure. Usiloxin is there, the complex usiloxin is there. It is in the middle, it is in the middle of the structure. The usiloxin A is there, not B, it is A, usiloxin A. B and A are almost same, just the orientation of the amino acids. So that is that, another thing, nothing difference, but this is the complex structure of the Clauster Simmonna mycotoxin. So this is, you can see in the display, in the screen, you can see this is the structure of the mycotoxin.